Hello everyone, so it's good to see y'all again. I'm Tasha and welcome back. So today we're going to discuss about our fifth chapter. So it's complex numbers and quadratic equations. So in this video, we're going to be discussing about the Argand plane, which we can also call as a complex plane, right? Yeah. So today, we'll be discussing about the modulus of a complex number in the Argand plane. So let's have a look at some of these topics. So let's get started. Okay. So first of all, what's your topic? It's about Argand plane, right? So I'm gonna just write the heading. Oh, just wait a second. Yeah. Okay, so let's continue. So what's gonna be the main heading? It's gonna be Argand plane. So let me just write it here. Argand plane. You can even say Argand plane or Argand plane. That's your choice. Okay, doesn't matter at all. Okay, so Argand plane or complex plane, or it has some few other names too. Well, I can't remember them right now, but they have some few more names. So for now, I know about the Argand plane and the complex plane, but there's another name too for them. I can't remember actually. I think I forgot. Okay, I'll try to remember if. Okay, whatever. It's not in my mind, so how can I say that? Okay, so with the Argand plane, what's this Argand plane? But before discussing about the Argand plane, I want to, draw something right here. And that is going to be, related to our today's topic. So that whole thing is going to be related to our today's topic. Okay, so I'm going to draw a graph. Well, yeah, this time I promise you it's going to be absolutely a graph. And with all the four positive and negative axes. So it's going to be positive x, y, negative x, okay? Here we're having our origin, okay? How many of you think that this is 0? How many of you think that this is 0? Or origin, well, of course it's origin, but you know what, we can say that this is also 0. But sometimes we get confused, is it 0 origin? But of course it is origin, it is the origin. But according to the number line, as it's starting from, and then the right hand side is starting from positive 1 and the left hand side starting from negative 1, which means, and between these two numbers, only one number is there and there's only 0. So which means that it's actually 0. And yeah, one more thing, that if we're gonna have a look at our origin, what's our origin? It's 0, 0. So for the value of x is equal to 0 and for the value of y is equal to 0. Okay, that's what it's trying to say. The origin 0, 0. I've already told this. I had told it about this a long time ago. I can't remember when did I discuss about it, but when did I describe it so. Never mind. Yeah, let's get back here. Yeah, so what we have is I'm gonna write some few points. Okay, I'm gonna mark some few points. So how about I draw something here? I'm gonna say point A. Let's discuss about the Argand plane. So before moving on to the points. Oh no, actually they're the points in graph, but they're actually the complex numbers. They're not the points. They're the complex numbers, which we're gonna describe here. But yeah, right after the definition, and a small statement, a small definition I can say about the Argand plane. What's this Argand plane? Okay, yeah. So I'm going to be writing that the plane, but of course it's a plane, so the plane having let's start it. So the plane having is it straight? Okay, that doesn't even matter. Yeah, so the plane having a complex number assigned, a complex number assigned it's talking about the various points that we're having in a plane. So the plane having a complex number assigned to each of its point, to each of its points is called Argand plane or complex plane. That's what we can say, right? Yeah. So to each of its point is called complex, let's say Argand first, okay? Argand plane or complex plane, right? Complex plane. Okay, so this what we're having here is that the plane having a complex number assigned to each of its points is called Argand plane or complex plane. Okay, that's what we can see. So about which points are they talking about? About which points is it talking about? So those are the points which are actually the complex number, and that I'll be just writing them in the graph. Okay, so let me start with the points. Okay. So, but before that, I'm going to write, we have a total 7. We have total 6 to 7, 6 to 7 complex numbers here. And, we'll be mentioning it on the graph too, in the plane too. Well, I'm going to say this, I'm going to say plane instead of say, graph. Okay? Yeah. So, first we have our A, but yeah, remember, I think I've always told you that usually complex numbers are denoted by symbol Z, but we can just, we can denote them by any other symbol too, because it's not, compulsory or something, okay? It's not fixed or anything. So we can actually use any other alphabet too, any other letter too for that. Okay, so right here I'm going to use A. And there will be I'm gonna say that I'll be using 6 complex number, okay? 6, I think 6 are enough. 6 is enough. So A, so I'm gonna write this so that this complex number A is equal to 2 plus 4 iota. Then B is equal to, how about taking negative values? Should we take negative values? Why not? So negative 2 plus 3 iota, then let's say we have complex number C, which is equal to 0 plus 1 iota. Let's say we have complex number D, which is equal to 2 plus 0 iota, right? Yeah. Let's say one more, okay, last second, which is the complex number E. Yeah, actually I was about to say set. Yeah, I was about to say set E, but we're not talking about sets, we're talking about the complex numbers. Okay. Yeah, so we have our complex number E, which is equal to, okay, so what if in a condition we, the real part, both the real part and the imaginary part, both are negative. Then what does that mean? How are we going to represent it in the plane? How are we going to show them in the plane? So they will be at a little different place according to their values, their negative and whatever they are, okay? So let's get back here. So complex number E, which is equal to negative 5 minus 2 iota, and last is complex number F. So F, which is equal to positive 1 minus 2 iota. Okay, so I think that these 6 complex numbers are enough. So now how are we going to represent them, all these, in the plane, in this plane? So first of all, I will have to, or maybe not. Okay, I will have to actually just clean this plane, because it will take some place right here too, but I don't have any space here left, so I'm gonna just make it furthermore there. Okay, a little bit here, so I'm just gonna shift it, move on there. Okay, I think that this is enough. Okay, so what do we have is what we're having is x, y, negative x, and negative x right here, not here, and this is negative y, right? Ooh, it's in y now. Yeah, so positive x, positive y, negative x, and negative y. So it's just like, okay, what if I'm going to talk about this direction, like going in something, some object or object going in this direction, in this form, like, what is it going to be? Is it going to be an anti-clockwise direction? Because I think that, clockwise direction is actually like this way, right? Yeah. This is going to be anti-clockwise and clockwise just like this way. Actually, we'll be discussing about some of these few things in polar representation, in the polar form of complex number. But yeah, that's not, but we're not discussing that topic right now, so, okay, so let's get back here. Yeah, so our point A, which I'm going to draw, how about here, okay, as it's positive. Well, that doesn't even matter even if it's positive. 2, 4, okay? That's what the values are given to me. Real part and the imaginary part. How about taking the value b, because it's a negative. So why not we take right here b, which is equal to negative 2, 3. Right? Yeah. Now the C1, real part is 0 and the imaginary part is 1. So let's draw it right here, okay? C, which is equal to 0, 1. Now the D is 2 plus 0 iota. So point D is going to be here, so which is equal to 2 plus, not here, plus 2, 0. Now the next one, E, which is negative 5 and negative 2. So according to me, like it's negative 5 and negative 2. So just right here, okay? Just right here. So point E, which is equal to negative 5, negative 2. Well, I think it's too small, right? Yeah, it is small. I'm gonna write it more bigger because it's too short. Yeah, point E, which is equal to negative 5, negative 2. Now the point F, which is, so positive real part and a negative 2 iota. So I think according to me, it's gonna be right here. Point F, which is equal to 1 minus negative 2 iota. No, it's absolutely wrong. Actually, we're having our x-axis, the real part 1. So I think it's gonna be right here, okay? Okay, I'm gonna just, make them correct. Because, wherever I'm writing them, they're actually in order. Now I'm gonna tell you how, okay? Let me just write this, then I'm gonna tell you that how is it? Like, why am I writing here, not like why not somewhere else? So, just wait a second. 2. Yeah. Oh, come on. Okay. D, which is equal to 2. Come on. Okay. Why do I always forget about this? Okay, never mind. Yeah, f, which is 1 minus 2 iota. So actually the point is not going to be right here. Okay. It's going to be right here, okay? I think, yeah. F, which is equal to 1 minus, 1 comma negative 2. Okay, so now let me tell you how. So I've written like all these complex numbers at their point. Now let me just mark the numbers so that you will not forget about it. So this is 1, this is 2, this is 3, 4, and how about making it more bigger, more longer, okay? And this is 5. Wait, I don't think there's any need to make points for them, but okay, never mind. Okay, I'm just gonna write them, okay, just like the way they are. Yeah, so because I don't want to make it all again, so whatever it is, I'm okay with it. Okay, so here it is -1, -2, -3, -4, and here I'm having -5. So which means that this point E is going to be right here, okay? Point E. Okay, wait a second. Right here, okay? Yeah, here I'm going to write -1, -2. Oops. Okay. It has really become a mess. Why not rewrite it again? Because I think that it's more better to, draw these all things again rather than, just making them more and more dirty, whatever. Yeah, okay. This time, I'm not going to erase it. Yeah, X, Y. Let's just, do it really fast. Oh gosh, why do I always forget about this? Why can't I remember it? Okay, so -x, and here we're having our origin. 1, 2, 3, 4, 5. Right? -1, -2, -3, -4, -5. Right? Here 1, 2, 3, 4, 5. And here I'm having -1, -2, -3, -4, -5. Okay, finally I've done this. Okay, so now let's understand it, in more detail and clearly. Okay, like no other detail, like I've already tell everything about it. Okay. Like more clearly we're gonna understand it. Okay, so what is it saying? The first one we have is 2 plus 4 iota. Okay, this 4i is which is gonna be y. 2 is gonna be x-axis. This 2 is the real part and 4 is the imaginary part, right? So where is 2? 2 is right here. So I'm gonna make a point right here, but before that, which is 4. 4. So the point is gonna be exactly right here. Just below the 2 point and just the side, the fourth point, So this is how I'm going to say this, that first this A is equal to 2, 4. Okay? So now the next one, -2 plus 3 iota. Let's do it fast, okay? Because it's going to take a lot of time if I'm gonna discuss this slowly. Okay, -2 plus 3 iota. -2 is just right here, okay? 3 iota in the y. So which is going to be, just right here. Okay, 3 and 2, right? -2. So this point is going to be B, and B is equal to -2, 3. Okay, now let's move on to C. C is 0. plus 1 iota. Okay. This is interesting. Like, it's actually going to be 1 iota, which means that it's going to be right. Okay. It's going to be actually just right here, just, at the point. Okay, so which is going to be C, which is equal to 0, 1. Right? Yeah, which is just right here, just above the 0 and, just beside the 1. Okay. Just, right after the 1. Okay, now the next one, 2 plus 0 iota. 2 and 0. So which means that's going to be just right here. The point is point D is right here, which is 2, 0. Okay, so let's move on to E, -5, -2. Okay. -5 and -2. So the point is going to be just right here, which is equal to E is equal to -5, -2. Okay, now the point F, 1 minus 2 iota. Okay, 1 minus 2 iota. So which is going to be just right here, F point, which is equal to 1 minus 2. So 1 minus 2. So this is like through this way how we're going to, through this way, like we're going to represent all these complex numbers, just right at the points, okay, nowhere else. Okay, so like this, what I can say, the order, the order of the numbers. If, -5 is just right, and then, draw that point just below -5. Okay, not at the -4, -3, just right at the -5. Okay, so that's what I did. So I think like this is all right. Like this is clear to you, right? So like we'll be also discussing about the modulus of a complex number. Okay. We'll be discussing about the modulus of a complex number, but yeah, which is our next topic. Okay. So which means that we'll be discussing about this topic in our next video, because I think that's all, that's enough for today, because I took too much time, it took me a little too much time, to study about these things, to discuss about these things with you, okay? So I think that I will discuss this, in the next video. So next topic, this is our next topic, modulus of a complex number. Okay, so that's all for today, and in the next video, which I just already told you, so thanks for watching and have a great day.